Lakshmi Prasanna, Assistant Professor, Department of ECE, Institute of Aeronautical Engineering. In this session, we will discuss about register set of 8051 microcontroller. So, we have to know, based on the architecture of any microprocessor or microcontroller, how many number of registers are available inside that particular target processor or controller. So coming to 8051 microcontroller register set. So the internal RAM, which is also called as data memory of 8051 microcontroller, will be divided into different categories. So here the internal RAM memory is available inside 8051 microcontroller. This RAM memory is being divided with the help of different registers, like some amount of RAM is given to store this general purpose registers and bit addressable registers, register banks and special function registers. So all these are the registers that are present inside the internal RAM of 8051 microcontroller. Now we will discuss about all these registers in detail. So 8051 microcontroller consists of different special function registers. So the special function registers can also be represented as SFRs. Okay. So here these SFRs are used to program and control different hardware peripheral devices like timers, serial ports, IO ports. So all these peripheral devices can be programmed with the help of special function registers. Now, so here we have different special function registers. Among these special function registers, some of the registers comes under bit manipulation registers. That means by manipulating some of the bits that are available in the registers of 8051 microcontroller, we can access or change the operating modes of 8051 microcontroller. Now, so all these are different registers that are available in 8051 microcontroller. So some of the special function registers are given here. Among all these special function registers, some of the registers are bit addressable, whereas some of the registers are not bit addressable. So first register here is ACC. We can simply represent this register as A. So this register can be called as accumulator. This accumulator register is having its fixed address in the internal RAM space, that is E0H. And next register is B, which is called base register. And the fixed address in the internal RAM address space for this register is F0. And another register is PSW. So here PSW stands for program status word, which can also be called as flag register. Its fixed address in the internal RAM address space is D0. And another register is SP, which is called stack pointer, and its fixed address is 81H. And here we have DPTR register. DPTR stands for data pointer. So generally it is a 16-bit register. If we wanted to use that 16-bit register as two 8-bit registers, we can use it as two 8-bit registers, that is DPL and DPH. So DPL stands for data pointer low byte and DPH stands for data pointer high byte. So for these two, it is having fixed address in the internal RAM space, that is 82H and 83H. And next special function registers are related to the ports. So in 8051 microcontroller, we have 4 ports: port 0, port 1, port 2 and port 3. Each port is having its fixed address in the internal RAM address space. That is, for port 0 it is 80H, for port 1 90H, for port 2 0AH, and for port 3 it is 0BH. And the next registers are related to the interrupts. It is IP register, which can also be called as interrupt priority control, and its address is 0B8H. And some more special function registers are here. And next one is IE. So here IE stands for interrupt enable. This register is also related to interrupts. Its fixed address in the internal RAM address space is A8H. And next two registers are related to timers. Two timers are available in 8051 microcontroller. And here one register is TMOD, which represents timer mode register. Its fixed address is 89H. And another one is TCON, which represents timer control register. Its fixed address is 88H. And so generally we have two timers in 8051 microcontroller. Here the two timers, each timer is of 16-bit. We can use that 16-bit timer as two 8-bit timers. One is TH0 and TL0. These two are related to timer 0. Lower order 8 bits represents TL0 of timer 0, and higher order 8 bits of timer 0 will be handled by TH0 register. Their fixed addresses are 8CH and 8AH. And the next two registers are related to timer 1. Timer 1 is also 16-bit register. It can be used as two 8-bit registers as TH1 and TL1. TH1 is a register which holds the timer 1 higher order 8 bits. Its fixed address is 8D, whereas TL1 holds the lower order 8 bits of timer 1 and its fixed address is 8B. And next two registers are related to serial communication, that is SCON. So here SCON represents serial control register. Its fixed address is 98H. And another register is SBUF. So SBUF represents serial buffer register and its fixed address is 99H. And this is the last register, which is called PCON, power control register, in order to control the power, and its fixed address is 87H. So all these are the fixed addresses for these special function registers. So in order to access these registers, it is possible with the help of all these fixed addresses. So among all these different SFRs, special function registers, some of the registers are bit addressable, whereas some registers are not bit addressable. So for some registers, I have indicated here star mark. Okay. So to whatever the registers I have indicated here star mark, those registers are called bit addressable special function registers. That means if you wanted to change any one of the bit in that particular register, it is possible without disturbing other bits in the register or without changing the function of other bits. And so let us discuss about all that registers that are available in 8051 microcontroller. So here first classification of registers, here it is CPU registers. So under CPU registers, what are all the registers comes here means, one is A register, which can also be called as ACC, that is accumulator register. Another one is B register. So these are the two registers that are called as CPU registers. Now we will see what is the function of this A and B registers. Now, so first is here, we will talk about A register. So A register can also be called as accumulator register. This is one of the basic register that can be used in 8051 microcontroller, which is available in the special function register. So accumulator is the most important and most used 8051 microcontroller register. And register A is located at an address E0H in the SFR memory space. So its fixed address is E0. And accumulator is used to hold the data for all the arithmetic and logical operations. So in order to do any arithmetic and logical operations, we can use in order to force the operand, or after performing the operations, in order to store the result, we can use a register accumulator. And so generally during programming, where we can use this A register means when we are going to perform the arithmetic operations like addition, subtraction, multiplications and all, we can use this A register. And while performing the logical operations like AND, OR, NOT, so in all these cases also, we can use the accumulator register. So in order to perform any data transfer operations between 8051 microcontroller and external memory, we can use this A register. How means, the name we can see here, accumulator, means it is a register used to accumulate. That means it is a register used to store the result of all the arithmetic and logical operations. Especially here, accumulator can be used to handle one of the input. After performing some arithmetic or logical operations, when we get the result also, the result can be stored in the accumulator. And this accumulator is an 8-bit register. So it is having 8 bits, that is from bit 0 to bit 7. And this accumulator is having the fixed address E0. When this accumulator is reset, this register will hold all the bit values as zeros. So during reset, accumulator value will be 0. And another CPU register is here, B register. So the B register is used along with accumulator. In order to perform any multiplication or division operations, we have to use this B register along with A register. Now, so these two operations are performed on data that are stored only in the registers A and B. So for example, if you take multiplication operation, so in order to perform this multiplication operation, we require 2 operands. So in such cases, one of the operand can be stored in A register, another operand can be stored in B register. After performing the multiplication operation, we will get the result. So in that result, the lower bits will be stored in A, whereas the higher byte of the result can be stored in B register. Now, like in the same way like multiplication, if you are going to perform some division operation, then how we are going to use this B register? So while performing the division operation, the B register holds the divisor and also the remainder of the result. So when performing division operation, to handle one of the input, that is divisor, we can use B register. After performing the division operation, we will get the quotient and remainder as a result. So among these two, this B register will hold the remainder value. And it can also be used as general purpose register for normal operations and is used as auxiliary register by programmers in order to store any temporary results. And so the register B, it is having fixed address. The fixed address is F0H in the SFR address space, and it is having all the 8 bits, that is from bit 0 to bit 7. When this B register is reset, this B register will hold all the bit values as 0. All the bit values will be 0 when this B register is reset. So that is what about the CPU registers. Next type of register is PSW register. So here PSW stands for Program Status Word. So PSW, Program Status Word, it can also be called as flag register. So after performing the arithmetic and logical operations by the ALU unit, the result will be reflected on the flag register. So the PSW consists of flag bits, which helps the programmer in order to check the condition of the result or the status of the result. So this is the format of PSW in 8051 microcontroller. So the flag register is of 8-bit size and it is having fixed address D0, and when this flag register PSW is reset, all the bits will hold a value 0, and it is having totally here 8 bits. Here one of the bit is P, it represents parity bit, another bit is not defined, and this bit is OV, which represents overflow, and these are the 2 bits RS0 and RS1, which are used to select the register banks, because here we have 4 register banks, and this is F0, which represents the flag bit, and this is AC, auxiliary carry flag, and this is CY, which represents carry flag. Now, so here are the functions of all the 8 bits that are present in the flag register format of 8051 microcontroller. So here we have 7th bit, which is C or CY. It represents carry flag. That means during arithmetic, logical or boolean operations, there is possibility of setting this carry flag bit. Now, and next flag is here AC, which represents auxiliary carry flag. And this auxiliary carry flag, generally it will be used or it will be set during this BCD arithmetic operations. And next flag is F0, which represents it is flag 0, and it can also be called as general purpose user flag. And next 2 bits are RS0 and RS1, which is called register selection bits. With the help of these 2 bits present in the flag register, the register banks will be selected. If it is 00, bank 0 is selected, 01, bank 1 is selected, 10, bank 2 is selected, and 11, bank 3 will be selected. So, though there are 4 banks available, at a time only 1 bank will be operating. And next flag is OV, which represents overflow. This flag is used in arithmetic operations. And next flag is not defined, it is reserved. It may be used as a general purpose flag bit. And 0th bit is here P bit, which represents parity bit. So it is set to 1 if A has odd number of ones, otherwise that P bit will be reset. So this is what about the function of each flag bit that is present in the PSW flag register format. And next type of registers are called pointer registers. And here are some of the pointer registers. DPTR. So here DPTR stands for data pointer, and another pointer register is SP. So here SP represents stack pointer. These are the 2 pointer registers that are available in the register set of 8051 microcontroller. And coming to the first pointer register, that is DPTR, which is called data pointer. So this data pointer is a 16-bit register. If we wanted to use them as 2 8-bit registers, we can use it as DPL and DPH. So DPL represents data pointer low and DPH represents data pointer high. And So the data pointer can be used as a single 16-bit register, or it can also be used as two 8-bit registers. So in the SFR memory space, we have fixed address for this DPTR register, that is which is classified into two 8-bit registers, that is DPL and DPH. So DPL fixed address value is 82H in the SFR memory space, whereas DPH register, 8-bit register, it is having fixed address in the SFR address space, that is 83H. And so generally this data pointer register is used by the programmer, which when he has to access this external memory. The external memory may be either program memory can also be called as ROM, or it may be data memory. So data memory can also be called as RAM. So if the programmer, in order to address this external memory, this DPTR register can be used. So here this is a DPTR register which is of 16-bit, that is here it is from bit 0 to bit 15. Okay. So these 16 bits are divided into two 8-bit registers. So that is from bit 0 to bit 7, which is called DPL, data pointer low, and bit 0 to bit 7, which is called DPH, that is data pointer high. So this DPL, it is of 8-bit. When it is reset, all the bits present in DPL will hold a values 0. And for DPL, the fixed address in the SFR address space is 82H. And DPH, data pointer high, it is also an 8-bit register. And when this DPH register is reset, all these bits will hold a value 0. So the fixed address for this DPH register is 83H. Another pointer register is stack pointer. So here the stack pointer, it is a register which always holds the address of the top of the stack, and it indicates the next data that should be accessed. So here stack pointer can be accessed by using different instructions like push instruction, pop instruction, call instruction, and return instructions. So how to access this stack pointer register means, during accessing of all these instructions, the stack pointer register can be used. And so generally the stack pointer register is a 8-bit register. When the stack pointer is reset, it holds a value 07H instead of 00. And so when writing a new data byte into the stack pointer will be automatically incremented by 1, and the new data will be written at an address SP plus 1. So during the writing operation, the stack pointer will be incremented by 1, but whereas in another condition, that is when reading operation is performed, the data will be retrieved from the stack. So the stack pointer will be decremented by 1 and the new data will be written at the address SP minus 1. And so this is the general format of stack pointer register format. So when this stack pointer is reset, it is going to hold a value 07. So if you observe here, this is 0000, which will be equivalent to a value 0. And here 0111, which is equivalent to a value 7. So when this stack pointer is reset, it will hold a value 07. And it is having a fixed address in the SFR address space, that is 81H. And so that is what about the pointer registers. And the next classification of registers that are available in 8051 microcontroller is IO port registers. So here IO port registers means it is related to the port pins of 8051 microcontroller. As we know, 8051 microcontroller is having 4 ports, that is port 0, port 1, port 2 and port 3. Each port is of 8-bit size, and this one port, same port will be acting as IO port because the port is bidirectional. Now, so IO port registers, as 8051 microcontroller is having 4 ports, those ports can be used as input port or output port. So here are the 4 ports: P0, that is port 0, P1 port 1, P2 port 2 and P3 port 3. And so for all these ports, they are having fixed address in the SFR address space. The fixed addresses are: for port 0, the fixed address is 80H, for port 1, 90H, for port 2, A0H, and for port 3, this is port 3, it is B0H. And so each bit in these SFRs corresponds to one physical pin in 8051 microcontroller. So all the port registers are both bit addressable as well as byte addressable. So writing 1 or 0 on the port register bit will reflect as an appropriate voltage, that is 0 volts and 5 volts on the corresponding pin. That means if we write the value 1 onto the port pin, it indicates 5 volts. If we write a value 0 onto the port pin, it indicates 0 volts. And so if particular port bit is set, it is declared as 1 and the corresponding port pin will be configured as an input port. In the same case, if port bit is cleared means if that particular bit, any of the bit in the port bit, it is cleared means that particular bit value will be 0. The corresponding port bit can be used as output pin. Okay. So because these port pins are IO ports, that means they are bidirectional. They can be used as input pins or output pins. So in order to use as input pin, we have to set that particular port pin. In order to use them as output pin, we have to clear that particular port bit. So upon reset, that means when the port register is reset, all the port bits are set to 1 and all the port pins are configured as input ports. Now, so here are port 1 and port 2 registers. Sorry, port 0 and port 1 registers. So this is port 0, which is of 8-bit. So from bit 0 to bit 7. When this port 0 is reset, all the bits will be handling a value 1. It indicates they are used as input ports. And the address in the SFR address space for port 0 is 80H. For port 1, when that port 1 is reset, all the port bits will be set to 1. The port bits will be used as input port and the fixed address in the SFR address space for port 1 is 90H. And coming to the next IO port registers, that is port 2 and port 3. So here are the formats of the 2 port registers. This is for P2. So port 2 register is of 8-bit in size, that is from bit 0 to bit 7. And when this port 2 is reset, all the bits will handle a value 1. That means the port pins will be used as input pins and it is going to have a fixed address in the SFR address space is A0H. And next port is P3. So here P3 is also 8-bit register. When this port 3 is reset, all the bits will handle a value 1. So handling a value 1 means those port bits will be used as input port pins and it is having the fixed address space in the SFR, that is B0H. So that is about IO port registers. Another classification is here peripheral control registers. So peripherals here are nothing but serial ports, IO ports, and also it consists of timers, counters. So all these comes under peripheral control registers. So here are some of the peripheral control registers. One is PCON register, SCON. So PCON stands for power control and SCON stands for serial control. And next one is TCON, timer control register, and another one is TMOD. Okay. So all these registers comes under peripheral control registers. So here these registers are related to serial communication, whereas these two registers are related to timers. And another peripheral control register is IE, which is called interrupt enable. And next one is IP, which is called interrupt priority register. So these two registers are related to interrupts. So these registers are called peripheral control registers. Now coming to the detailed discussion about all that peripheral control registers. The first register here, it is PCON register. So PCON stands for power control register. So generally this PCON register is used to control. So power control it is. So PCON register is used to control 8051 microcontroller power modes. And this PCON register is having fixed address in the SFR address space, which is 87H. And so here using 2 bits in the PCON register, the microcontroller can be operating in 2 power modes. The 2 power modes are here, one is ideal mode, another one is power down mode. So in order to set whether the microcontroller should be operated in ideal mode or power down mode, it is possible with the help of register, PCON register. And so this PCON register is not bit addressable register. Now, so 2 power control modes are there. So one is ideal mode and power down mode. So here what is meant by ideal mode means, so during ideal mode, the microcontroller will stop the clock signal to the ALU. That means it is going to stop providing clock signal for the ALU, but it is given to other peripherals like timers, serial, ports, interrupts. Okay. So the microcontroller will stop providing the clock signal only for ALU, whereas the remaining peripherals will be provided clock signal. So in order to terminate the ideal mode, we have to use an interrupt, or it is possible with the help of hardware reset also. And another mode of operation in the power mode is power down mode. So in the power down mode, the oscillator will be stopped and the power will be reduced to 2 volts. So to terminate power down mode, we have to use only one technique, that is, it is possible only with the help of hardware reset. And so this is the register format for PCON register. So here PCON stands for power control register. So it is an 8-bit register and here are the 8 bits. Its fixed address in the SFR address space is 87H. It is having 8 bits from LSB to MSB. Here, so first one is here, 7th bit. This is 6, 5, 4, 3, 2, 1, 0. So it is an 8-bit register. So here first bit is related to SMOD. Okay. So here SMOD, what is the purpose of that bit means? It is used for serial communication. Okay. So in order to set the baud rate, it is possible with the help of this SMOD bit. So for example, if that SMOD bit is 1, the baud rate will be doubled. If that SMOD bit is 0, we will have a normal baud rate. And so here from 4, 5 and 6 bits, if you see, they are not defined. The next bit is here, 3rd bit, that is GF1, which is called General Purpose User Flag bit. And next one is GF0, which is called General Purpose User Flag bit 0. And another here bit is PD and another one is IDL. So we have said by using this power control register, the 8051 can be operated in 2 modes. One is IDL mode and power down mode. So it can be operated in the 2 modes with the help of these 2 bits. So here one is PD, which is called power down bit. So if that bit is set, the microcontroller will be entering into power down mode. And if IDL mode bit, if that bit is set, it will be operating in IDL power down mode. So by using that PCON register, it can be operated in those 2 modes with the help of the 2 bits present in PCON register. And another register is here, SCON register, which stands for Serial Control Register. So this SCON register is used to control 8051 microcontrollers serial port operation. And so this SCON register, among all the SFRs, SCON register is present at the address 98H in the SFR address space. So using this SCON register, we can control the operating modes of serial port, and also baud rate setting is also possible for serial port and send or receive the data by using serial port. So that is the main purpose of SCON register. So SCON register also consists of bits that are automatically set when the byte of data is transmitted or received. We will see the SCON register format. So this is the format of SCON register. So here SCON stands for Serial Control Register. When this SCON register is reset, it is going to handle all the bits as 0, and it is present at the fixed address in the SFR address space, that is 98H. Now, so here it is an 8-bit register, and the first bit is here SM0, which indicates a serial port mode selection of bit 0, and next is SM1, which indicates serial port mode selection for bit 1, and next bit is SM2, so it indicates multiprocessor communication bit. Next is here REN, which represents receive enable bit, and here TB8, which represents transmitted bit 8. Okay. So with the help of this SCON register, it is possible to know how many number of bits are transmitted and received. And next is RB8, which indicates received bit 8. And here TI and RI indicates transmit interrupt flag and receive interrupt flag. So these 2 flags will be set after transmitting the data and after receiving the data. And so coming to SCON register, so in the serial port mode selection bits, because in the SCON register we have two important bits which are called SM0 and SM1. So with the help of these two bits, different modes of UART operation can be performed with the help of different baud rates. So here we have seen the two bits SM0 and SM1, which says the mode of operation. So if these two bits are 00, 8051 microcontroller will be operating in mode 0, that is serial port. And when it is operating in mode 0, 8-bit synchronous shift register mode, it is called. And its fixed baud rate, that means the frequency of oscillator will be divided by 12. If these two bits are 01, the serial port of 8051 microcontroller will be operating in mode 1. It is called 8-bit standard UART mode. Here variable baud rates are possible and it can be set by timer 1. If it is 10, it will be operating in mode 2, which is called 9-bit multiprocessor communication mode. So with fixed baud rate, its scaling factor, frequency of oscillator will be scaled by 32 or it may be scaled by 64. If these two bits are 1, 1, the serial port will be operating in mode 3, which is called 9-bit multiprocessor communication mode. It will be operating in variable baud rate and it can be set by timer 1. And next register is about TCON register, which is called timer control register. So this TCON register is used to start or stop the timers of 8051 microcontroller. And this register also contains some bits in order to indicate, to say whether the timers have been overflowed or not. So the TCON also consists of some interrupt related bits. So this is the general format of TCON register. When this register is reset, all the bits will be holding a values 0 and it is having fixed address in the SFR address space, that is 88H. So here we have seen it also consists of interrupt related bits. So here are the 4 interrupt related bits. Okay. And here these are the bits related to timers. Now, so it is an 8-bit register. So if you see here, the 7th bit, it is TF1. Okay. So TF1 represents timer 1 overflow flag. Generally, it will be set when the timer 1 overflows. And 6th bit is here TR1. TR1 represents timer 1 run control bit. It is used to enable the timer counter set to 1 or clear to halt the timer. And the 5th bit is TF0. So here it is related to timer 0. Timer 0 overflow flag. So this TF0 bit will be set when timer 0 overflows. And here the 4th bit is TR0, which represents timer 0 run control bit. So this bit is enabled in order to make the timer counter set to 1, or this bit will be cleared if you want to halt the timer. And another bits are IE1, that is external interrupt 1 edge flag. It will be set when high to low is received in INT 1 pin. That means this IE1 signal is related to INT 1 pin. And another one is second bit, that is IT1, which represents external interrupt 1 type control bit. So if this IT1 bit is 1, it indicates interrupt 1 occurs on the falling edge. In another case, it may be 0. When it is 0, it indicates interrupt 1 occurs on the low level of the clock cycle. And next bit is 1. It indicates IE0, which represents external interrupt 0 edge flag. If that bit is set, it represents the information is received at INT0 pin. If that bit is cleared, it indicates ISR have been executed at the address 00003H. And another bit is the last bit, that is 0 IT0, which indicates external interrupt 0 type control bit. And another register is TMOD register. So TMOD register is used to set the operating modes of timer 0 and timer 1. So the lower order 4 bits, it is also an 8-bit register. The lower order 4 bits are related to timer 0 and the higher order 4 bits are related to timer 1. So here this is the TMOD register having the fixed address of 89H, and these 4 bits are related for timer 0 and these 4 bits are related for timer 1. So here this is for 0, this is for 1. Okay, so this is for timer 0, this is for timer 0. Okay, so wherever we have indicated here 0, those bits are related to timer 0, and 1 means it is indicated to timer 1. So 7th and 3rd bit in the general format of TMOD register is G bit. It represents gate. Okay, so OR gate will be enabled if that particular bit is set. And 6th and 2nd, these two pins are related to C by TX. So here this X represents, it may be 0 or 1. If it is 0 means it indicates timer 0. If it is 1, it is related to timer 1. So C by TX means that bit is used to select a timer or counter mode. And 5th and 1st bit both are same. It is TXM1, which represents timer counter operating mode select bit 1. And another one is 0 and 4 bits. They are same, which indicates TXM0. So that bit indicates timer counter operating mode selection bit 0. So whether to select timer or counter, if it is selected, it has to be operated in which mode. And another bit here, gate X bit, it is used to operate the timer. X means here either it may be 0 or 1 with respect to INTX. Here also this X may be 0 or 1. So if that gate 1 bit is 1, it indicates timer 1 is operated only in TR1 is set and the signal on INT1 is high. So this gate 1 bit, it is related to the 2 bits, that is TR1 and INT1 also. And when this gate 1 is 0, it represents timer 1 is operated irrespective of the signal on timer 1 pin, but TR1 must be set. So these 2 bits are related to timer 1, whereas this gate 0, it indicates timer 0. When this gate 0 bit is set, it indicates timer 0 is operated only in TR0, that is in TCON is set, and signal on INT0 is high. So this gate bit is also related to this TR0 and INT0. And another one is gate 0. So when that gate 0 bit is not set, it indicates timer 0 is operated irrespective of the signals, that is INT0 and TR0. And next bit is C by TX bit. This bit in the TMOD register is used to select the source of pulses for the timer to count. And if C by T1 bit is set, it indicates, see here, T1 represents timer 1. So it indicates timer 1 count pulses from pin T1. If C by T bar is 0, it indicates timer 1 counts the pulses from internal oscillator. Next, so these two are related to timer 0 And next one is C by T naught, these two are related to timer 1 and another one is related to timer 0. If this is 1, it indicates timer 0 count pulses from pin T0, and if C by T0 is 0, it indicates timer 0 count pulses from the internal oscillator. And so the 2 bits in the TMOD register says the mode of operation. So this is a TM0 and TM1. If these 2 bits are 0, it will be operating in mode 0. Another name of mode 0 can also be called as 13-bit timer mode. If these 2 bits are 0, 1, it will be operating in mode 1, which is called 16-bit timer mode. If it is 1, 0, it will be operating in mode 2. And mode 2 can also be called as 8-bit auto reload timer mode. If it is 1, 1, it will be operating in mode 3, which is also called as 2 8-bit timer mode. Another name is split timer mode. So by using the 2 bits of a TMOD register, we can perform the timer counter operating in different modes. And next registers are here. Interrupt registers. First one is interrupt enable register. So this interrupt enable register is used to enable or disable individual interrupts. So this interrupt enable register is also an 8-bit register. If any of the bit is set, the corresponding interrupt only will be enabled. If any of the bit is cleared, that particular interrupt will be disabled. So bit 7 of IE register, that is interrupt enable register, is EA. Okay. So here EA, this bit is used to enable or disable all the interrupts. So if you see here, bit 7 it is EA. This indicates to enable or disable all the interrupts. So the fixed address here is A8H. Upon reset, all the bits will be cleared. And here you have EX0, ET0, EX1, ET1 and ES, ET2. Now the function of all these bits are given here. So the 7th bit is EA. It is called global interrupt enable bit. If that EA is set, all the interrupts will be enabled. If it is cleared, all the interrupts will be disabled. Next is 6th bit, which is not defined. Coming to 5th bit, it is ET2, which is called reserved. It is reserved bit. And the 4th bit is ES, which indicates a serial port interrupt enable bit. If this ES bit is set, it indicates serial port interrupt is enabled. If it is cleared, it represents serial port interrupt is disabled. And another bit is 3rd bit, which is called ET1. It represents timer 1 overflow interrupt enable bit. If it is set, timer 1 will be overflowed. And 2nd bit is EX1, which represents external interrupt 1 enable bit. If it is set, external interrupt 1 is enabled. If it is 0, external interrupt will be disabled. And next is 1 bit. It is ET0. It represents timer 0 overflow interrupt enable bit. If that bit is set, timer 0 will be overflowed. If it is 0, timer 0 overflow interrupt will be disabled. And last one, 0 bit, it is EX0. It represents external interrupt 0 enable bit. If that is set, external interrupt 0 is enabled. If it is 0, external interrupt 0 will be disabled. That is what about one of the interrupt enable bit. Another interrupt register is IP register, which is called interrupt priority register. So this register is used to set the priority of the interrupt either to highest priority or lower priority. So if the bit is cleared, that particular interrupt will be assigned the lowest priority. If any of the bit is set, it represents that particular interrupt will be having the highest priority. And this is the IE IP register general format. It is having the fixed address, in the SFR address space as B8H. When it is reset, all the bits will be handling the value 0. Now here this is PX0, PT0, PX1, PT1, PS and PT2. So this IP register is also an 8-bit register and all these are the bits present in that register. Now coming to the function of all these bits, here 7 and 6 bits are not defined and the next 5th bit is PT2, which is called reserved bit, and the 4th bit is PS, which is priority of serial port interrupt. If that is set, priority, highest priority will be given for the serial port interrupt. And the 3rd bit is PT1. If that bit is set, priority for timer 1 overflow interrupt. And the 2nd bit is PX1, which represents priority of external interrupt 1. And next bit is 1, that is PT0. It shows the priority of timer 0 overflow interrupt. And next one is 0, which is PX0. It shows priority of external interrupt 0. So all those are the peripheral control registers, and the last classification is peripheral data registers. So as we have discussed already about SCON register, now here it is SBUF register, which is called serial data buffer, and TL0, TH0, TL1, TH1. These two are the registers that are related to timer. And coming to SBUF register, which is called serial buffer, it is used to hold the serial data during transmission and reception. So that is why this SBUF register will be available at the transmitter end as well as at the receiver end. So this is the general format of SBUF register, having the bits from B0 to B7, and it is at the fixed address 99H in the SFR. And another data registers are TL0 and TH0. So TL0 and TH0 are the 8 bits that are related to timer 0. So here TL0 lower order byte and TH0 holds the higher order byte, and these together forms a 16-bit timer 0. So these are the general formats of that TL0 and TH0, which will be available at the address space 8AH and 8CH. And in the same way, TL1 and TH1 are the registers that are related to timer 1. So TL1 and TH1 are the lower and higher bytes that are related to timer 1. And here if you see, this is timer 1, which is of 16-bit in size. It can be divided into two 8-bit registers as TL1 and TH1. TL1 is a 8-bit register and TH1 is also an 8-bit register. When it is reset, all the bits in that register will hold a value 0. When this TL1 address space in the SFR is 8BH, and for TH1 the address space is 8DH. So this is what about the register set available in 8051 microcontroller. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.